Today you should have started by picking up a note packet, finding your assigned seat by locating where your table tent is, answering the student response number 2. What was your science grade last trimester? What helped you be successful, or what habits do you need to change to be more successful? And then work on the puzzle as a table. Today's checklist, you should watch the work screencast, complete the work lab, complete the lab conclusion on Schoology, and then work on the work practice on Schoology as well. Remember that you have unlimited attempts at that. And then when the yellow screen comes on, don't forget to complete today's reflection. The topic for today is work. Your essential questions are, what is work? And when do you do more work? So what is work? The physics definition of work is very different than how we use the term work in everyday conversation. Work is done when a force causes an object to move in the direction of the force. So for work to be done, two things must occur. First, a force must be applied to an object. Remember that a force applied is a push or a pull. Second, the object must move in the same direction as the force applied. If there is no motion, there is no work. Let's do some work examples. Reminder, in order for work to be done, you must have an applied force and it must be in the same direction as the movement. So let's take a look at this example. If you are pushing on a wall with all your might, but the wall doesn't move, have you done any work? So do you have an applied force? Yes, we have an applied force. But is the movement in the same direction as the force? That would be a no. So, no. No work has occurred. So why the wall did not move. And in order to do work, the object must move. So remember, no movement, no work. Let's take a look at a second one. If you are using force to hold a rock over your head while walking east across a field, have you done any work? So let's take a look at our reminders. Is there an applied force? Yes. Okay. Is it moving in the same direction? So if you're holding a rock over your head, your applied force would be going up, but you are walking east. So no, the force is not acting in the same direction, so no work is being done. So no. The applied force to the rock is going up, but you are moving east. The force and direction of movement are not in the same direction. Let's take a look at a couple more. Example 3. If you are using a force to pull your suitcase across the airport, have you done any work? So let's take a look at that. Do you have an applied force? Yes, you're pulling your suitcase. Is it in the same direction as the movement? Well, if you're pulling your suitcase to the left and you're moving to the left, it would be in the same direction. So, yes. The applied force is pulling in the same direction. You are moving. And one last example here. If you do a full push-up, lifting yourself up and then back down, have you done any work? Okay, so do you have an applied force? Yes, you're pushing yourself up and releasing back down. Is it in the same direction as the movement? This one's a little bit tricky. If you do a push-up where you start low, push up and come back down low, in the end, have you actually moved from your starting position? No. So no work has been done again. Why? Because you have not moved somewhere new. You ended in the same place that you started. So your distance is 0. Remember again, no movement equals no work. How do you calculate work? Work is equal to force times distance. It is also written as W equals F times D. The unit for work is joules, which is symbolized with a capital J. The unit for force, if we remember, is newtons, which is a capital N. And the unit for distance is meters with a lowercase m. Let's get some practice with this. Reminder, work is equal to force times distance. Whenever you do a calculation, remember to show your work and include your units. Example 1. You and 2 friends are on a road trip. Your car breaks down. 2 of you get out and each apply a force of 450 newtons to push your car 220 meters to the nearest mechanic. How much work did one person do? All right, so we're going to remember our equation. Work equals force times distance. So remember that force has the unit of N. So I'm going to go find my number with the unit of N. So that's 450 times my unit for distance, which is M. So times 220 M. If I type that into a calculator, I get 99,000. Remember, what is your unit for work? And that is joules. So your final answer, 99,000 joules. Let's take a look at example 2. You and 3 friends are on a road trip. Your car breaks down. 3 of you get out and each apply a force of 300 newtons to push the car 220 meters to the nearest mechanic. How much work did one person do? So same setup again. Work is equal to your force, 300 newtons, times your distance, 220 m. Type that into a calculator and you get 66,000. Don't forget your unit for work, which is joules. Example 3, what required more work? Example 1 or example 2, and why? So here we just look at the numbers, which number was bigger, example 1 or example 2. So the answer to example 1 had a larger number. So that one used more work. So why did it use more work? All right, taking a look at it, both examples push the car the same distance, but example 1 used more force. So because there was more force, there was more work done. Let's take a look at a couple more examples. Example 4. You push a refrigerator with 50 newtons of force over a distance of 80 meters. What is the work done? So remember our equation. Work is equal to our force, which has the unit of N. So find our number with N. So 50N times our distance, which has the unit of M, 80 meters. Typing 50 times 80 in the calculator will get us 4,000. And don't forget the unit for work, which is joules. All right, what about if you push a refrigerator with 50 newtons of force over a distance of 10 meters? What is the work done? So work is equal to my force times my distance. So if I type into a calculator 50 times 10, I get 500 joules. Let's take a look at example 6. What required less work? Example 4 or example 5, and why? Example 5. How do we know that? We take a look at our two final answers that we boxed, 4,000 and 500. Which one is the smaller number? 500. So example 5 did less work. So why? In both examples, they used the same force, but example 5 goes less distance. So if the force is the same, the fewer distance you go, the easier your work. Okay, make sure to answer the summary question. Now you guys have a work lab. So use your completed notes, a group, and a pencil. Read the instructions on the lab sheet. Use the video on Schoology if needed to further the instructions. Complete the questions. Hang on to it to use until the test. And next, you can work on the work practice on Schoology. Use your notes to help. Remember to continue taking that practice until you score at least a 3.5 out of 4. Then, if you still have time, you can work on the power screencast and notes. When the yellow screen comes on, don't forget to do the daily reflection. What might you have as homework? Anything on the checklist that was not completed. So you have now finished the work screencast. So now work on the work lab, the lab conclusion, the work practice.